Hello everyone. In this video we'll be working on the workbook questions which are there from chapter 3 in our science workbook. First we'll look at 3.1 which are forces and motion. Let's look at the first question from 3.1a, balanced forces. Now let's look at what the question says. What is needed for two forces to be balanced? Now we have to take two statements in the table. Let's look at those two statements. The first statement says two forces must be the same size. Yes, for balanced forces, two forces have to be of the same size. So this is correct. Okay. So this is correct. Let's look at the second one. Two forces must be of different size. No, that's not true. Two forces must be in the same direction. For balanced forces, two forces must be in the opposite direction. So the third one is also incorrect. Let's look at the last one. Two forces must be in opposite direction. That's the right answer. Alright, let's look at the second question. A box sits on the ground. The box is not moving. Write true or false after each statement. There is no force acting on the box. Let's say we have a box which is kept on a surface. The box experiences two forces. One, a force downwards which is caused due to gravity. That's called as weight of the object. And there is one more force which acts upwards, that is called as normal force or reaction force. Now, if you look at these two forces have the same size and they are opposite in direction, which means the forces are balanced. If the forces are balanced, then the box will not move. If it's at rest, it will stay at rest, but if the box is already in motion, then it will stay in motion. That's what inertia says. If I look at 2a, there is no force acting on the box. That's obviously false because we have a force. There are two forces acting. One is the force due to gravity and the normal force. Let's look at b. There are balanced forces acting on the box. That is true. There is an unbalanced force acting on the box. This is false. We know that this is false because in the question they have mentioned that the box is not moving, which means the box is at rest. If an object is at rest and if there are balanced forces acting on the box, then the box will not change its state of motion, which means if it's at rest, it will stay at rest. If it's at motion, it will stay in motion. That's what inertia says. Since it's already at rest, the box will remain at rest. Let's look at the third question. Sophia is riding her bicycle. The driving force on the bicycle is balanced with the force of friction on the bicycle. Draw the arrows on the diagram to show these forces. Write the names of the forces on the arrows. Now we have to write two arrows. One arrow facing to the right, you have to use a scale and a pencil to write it. Though this force is the driving force, so let's write down driving force. Then there is also one more force which acts in the opposite direction. That force is the frictional force. Let's write down frictional force here. Okay, so there are two forces acting on the bicycle. One is the driving force which tries to move it forward, and the other is the frictional force which opposes the direction of motion. So these are the two forces. Anyway, you know there are two other forces which act on this system. One is the weight of the system, like weight of the bicycle along with Sophia, which acts downwards. Then we have one more force, which is the normal force which acts upwards. But we don't have to mention this because they have only asked us to write about the driving force and the frictional force. So we don't have to mention these two forces, but we have to mention in which direction is the driving force and in which direction there is a frictional force. But make sure that both the arrows are of the same length. They should have the same length. This tells us that both of them have the same size. Both forces are of the same size, and they should be in opposite direction. So we have to make sure that these two conditions are satisfied. Let's look at 3.1b, unbalanced forces. Let's look at the first question. Which of these can happen because of unbalanced forces? We have to put a tick mark for the correct statement. A car will move at a constant speed. This is incorrect, because if there is an unbalanced force, let's say this is the direction in which the car wants to move. Let's say this is the driving force, and let's say there's a frictional force which is in the opposite direction. Okay. In the opposite direction there is frictional force. Now, this force is unbalanced because the driving force is larger than the frictional force. In such cases, the object will move in the direction of the driving force with an increasing speed. That means the speed will not remain constant. So the first option is incorrect. A boat will slow down. This can happen if there's an unbalanced force. Let's say in the second case, if I take a boat, let's say this is my boat and here I am. Okay. Now, if there's a boat which is going in this direction, that means this is the driving force in the boat. And let's say there's a force in the opposite direction. And if the force in the opposite direction is very large compared to the driving force, then the boat will slow down. It's like hitting brake in your bicycle. Right? Your speed will slow down. That means the force is acting in the opposite direction. Now, a football will change direction. That can be true. Right? Now let's say there's a football which is going in this direction, and suddenly there's a gust of wind which blows in this direction. Now the football will change its path. It will go in a parabolic path like this. So because the forces are unbalanced, the football will change its direction. A book will not move on a desk. This is incorrect. If there's an unbalanced force, the book will obviously move. Let's look at the next question. The diagram shows the force on a car. State which forces are balanced. We have 4 forces. One is the driving force and a frictional force. Then we have contact force and weight. By looking at it, we know that the contact force and weight are in the opposite direction, but they have the same length. That means the size of the force is the same. So let's write down contact force and weight are balanced. Then we have to tell which force is unbalanced. Let's look at the driving force and frictional force. The driving force has a larger arrow compared to the frictional force. That means the size of the driving force is larger than frictional force. So these two will be unbalanced. Let's write down driving force and friction. So these two are unbalanced. Now, what will happen to the car? The car will move in the forward direction, or you can say the car moves in the direction of the driving force, because the forces are unbalanced here. So let's write car moves forward. You can also write car moves with an increasing speed, because there's a force which is acting on the car and the car's speed will increase. But if the driving force and the frictional force were the same, if these two forces were also balanced, then the car will move at a constant speed. Let's say you are going on a highway with a speed of 60 km per hour. You will keep moving at the rate of 60 km per hour. Your speed will not change if the driving force and frictional force are balanced. But if your driving force is larger than frictional force, then your speed will increase. Your car will go to 60, then 70, then 80 and so on. But if frictional force is larger than driving force, then your car will start to slow down. You'll eventually come to 50 km per hour, 40 km per hour, and so on. Let's look at 3.1c, changing direction. Now, let's look at the first question. The diagram shows the forces A to D acting on a bird when it's flying. Describe the effects of these forces on the movement of the bird. Now we have four forces. Now let's say there is force B which is trying to push the bird forward and force D which is trying to push it in the opposite direction. Let's write what is force B. Force B is the driving force. Then force D will be frictional force because the bird is flying in air. Let's just call it air resistance. Now C is acting downwards, which means C is caused due to gravity. So this will be weight of the bird. And the bird is trying to overcome that weight, overcome that force by applying a thrust upwards, or this is also called as lift. Now in the A part of the question, we have to describe the effect of these forces on the movement of the bird. Let's look at these forces. Let's say force B and force D are of the same size and it's in the opposite direction. That means these two are balanced. Similarly, force A and force C are also balanced. If force B and force D are balanced, then the bird will move with a constant speed. And if force A and force C are balanced, then the bird will move at a constant height. So let's write down the bird flies. The bird flies with a constant speed. The bird flies with a constant speed and at a constant height. Alright, let's look at the next question. Describe one change needed to the force for the bird to go higher. If the bird has to go higher, we can make two changes. One, we have to increase the force A. If I increase the force A, the bird goes higher. Or I have to decrease force D. Now, if I want to increase force A, the bird has to just flap its wing harder, so it will go up. So that is possible. But can I decrease the force C, which is can I decrease the weight of the bird mid-air? That doesn't look very rational. So let's keep with the first one. Let's say we have to increase force A. So the one change required for it to go higher is by increasing force A. Now, we have to describe two changes to the force that would make the bird go slower. If I want the bird to go slower, either I have to decrease the driving force or I have to increase the air resistance. If I decrease the driving force, the bird will go slower. Similarly, if I increase the air resistance, if there's a wind in the opposite direction, the bird will definitely fly slower. So let's write down those two as the answer. The first one is decrease force B, or we can increase force D. Okay. These two changes are required to make the bird go slower. Let's look at this question. An aeroplane is flying north in a straight line at a constant speed. The aeroplane needs to turn towards east. Draw an arrow on the diagram to show the direction of the unbalanced force needed to make the aeroplane turn east. Now, my aeroplane is right now going towards north. It is flying straight. If I want it to go towards east, then I have to apply a force to the right. So, if I take my aeroplane and if I apply a force to the right, this creates an unbalanced force which causes the aeroplane to move towards east. So this will be the answer to our question. Let's look at this question. Tetherball is a game. A tennis ball is attached to a string. The string can rotate around a vertical pole. The tennis ball moves in a circle around the pole. The tennis ball in the diagram is moving in the direction shown. Draw an arrow on the diagram to show the direction of the unbalanced force on the tennis ball. Label this arrow F. So for those of you who don't know what a tether ball is, I'll show you a small video with which you can understand. Okay, let's take a look at it.
Well, that was a good one.
Alright, I hope that gives you a picture of what tether ball is. So we have a ball attached to a vertical pole. Now the ball will go around it. Assume it goes around in a circular path in an idealistic situation. And we have to draw an arrow on the diagram to show the direction of the unbalanced force on the tennis ball. Now, if the ball is going in a circular direction, that means there's a force which is acting towards the center. So there's a force which acts towards the center like this. This force is the central force which makes the ball go in a circular path. So let's label this arrow as F. Let's look at the B question. The string breaks when the tennis ball is at the position shown. Draw another arrow on the diagram to show the direction that the tennis ball will move when the string breaks. Label this arrow D. Now let's say for some reason the string breaks and we know object wants to go in a straight line. So this will take a tangential path, which means it will go with an angle of 90 degree with this string, and it will go in this direction if the string breaks. So let's call this arrow as arrow D. So this will be the direction in which the ball moves when the string breaks. Alright, make sure that you draw all these arrows using a pencil and a scale in your book. Make sure to put the proper letters to denote the arrows. Alright, I hope this video was useful and I'll see you again in the next video. Bye.